Hello everyone, my name is Matt Stoner, here on a project for the Cosmic Calendar. What is a cosmic calendar, do you say? Well, we take the existence of Earth, imagine Earth from its very beginning, which is, I don't know, what is it, 4.5 billion years or something like that. We try to put that into a calendar. We try to do that on a piece of paper on a timeline. You get towards the end, it's going to be all mashed in, all these events happening and stuff like that. And be really hard to understand. So what I'm going to try to do here is, if we look around here, I got all these placards here. I got some going all the way back here. So we got 200 meters where we're going to make our own calendar. So if we say the existence of Earth started on January 1st, start looking back all the major events up until the present day, what would that look like on a calendar? Well, we're going to take 200 meters and try to show that to you. Now, hopefully you can hear me. It is very windy here. I'm in St. Charles, Missouri, just outside of St. Louis. And kind of the weather's changing. We're about, I don't know, 75, 80 degrees today. And it's very, very windy. I think last Wednesday we were at 40 and had snow on the ground. So as I'm walking back here to my January 1st, hopefully my signs are still in place. The wind's been blowing them. Looks like we might be good to go here. Don't see any casualties yet. So if we go back to January 1st, and this is one of some of these things I'm just going to kind of mention, you know, just in passing. There's really too much. I don't want to make this a 45-minute video. But there's a few items I'm going to touch on and just give a few little other notes on. So if we come back here to January 1st, formation of Earth, you know, 4.6 million years ago. You know, so back then the Earth is just accumulation of dust and rocks, gases, very hot, volcanic, molten lava type Earth. They call this the Hadean era. And some say, you know, that's because of the hot volcanic time that was. That's where they got the term Hades, you know, hell. It's hot and miserable. You know, then we come to about January 17th. We got the formation of the moon. So it's about 4.4 billion years ago. And then right next to that, actually almost the exact same time, is the formation of the Earth's core. Some people say it's kind of the same thing, you know, the same event could have caused both of those. The large Mars-like shaped asteroid actually struck the Earth, and debris from that caused the moon. The rest of it kind of solidified our core. Then we got January 25th. We got our crust. It's forming. Earth's starting to cool. So it's very windy. It's hard to see my notes and the boards here. January 29th. We got impacts. Deliver simple simple organics. You know, asteroids, meteors are hitting Earth, delivering simple organics, which we needed, which helped shape and evolve life. These organics that started bringing in. Coming up on February 1st. And pretty much I put these together right next to it, February 2nd. A million years has passed. Oh, I'm sorry, as millions of years have passed, the Earth is starting to cool further and further. We're starting to get water and whatnot. And as it's cooling, water vapors created, and our atmosphere is holding all that in. It starts raining and raining and raining. It rained for tens of millions of years. That brings us up to February 15th, where the oldest rock is found. We know it come from about that time. And we're February 22nd. Heavy bombardment of asteroids starting to end. I don't want to lose my selfie stick here. Then we're hitting March 1st. March 2nd is our earliest evidence of life. Isotopic markers are found. And also, we're 1 billion years old, I believe, right about now. Happy birthday to Earth. So you see, keep kind of coming down here in this timeline. We're already into, the end of March here, March 29th. Here we go, Earth's 1 billion years old, just about. March 29th, right after that. We have the oldest living fossils are found. This is going to be really tricky here. I got to turn the page, and it is so windy. Keep aligned here with the sun. Now we're heading into May. We got April 1st, right down there. And we got to walk a little bit here because we go from April. Not much is going on for a little bit here. May starts. So here's we have the oldest record of Earth's magnetic field, and that's kind of an important thing. We're starting to get rocks containing organic minerals. It kind of helps, shows proof of Earth's magnetic field. And this is important because our magnetic field kind of helps us shield us from this big guy up here, the sun, the UV rays and whatnot, and helps protect us from, asteroids and meteors. So then we're coming down to May 24th, and the Earth is now rotating in 15 hours. So things are starting to slow down. We were going really fast, and we're starting to slow down. Things are starting to come into place. And then we hit June 1st. And this was probably the hardest part of this whole project, is pronouncing this word, and I hope I get this right. So on June 1st, we had our first single cell with a nucleus, the eukaryotes. I had to listen to that over and over to say that word, eukaryotes. We come up here on June 9th. We're 2 billion years old. Happy birthday again. We're just moving along. We go here, lost my place. Oh, June 17th. You can see right there, our oxygen is 1 to 2%, so oxygen is really forming, which again helps life grow. Come down here to June 25th. This is the oldest evidence of a snowball Earth. Most of the Earth would be covered in snow and ice at this point. July 1st, right there. And again, not much happens between July, August, even September into October, really. Earth's just spinning its wheels and getting older. It's cold. There's August. We're trucking all along. We're gonna hit August 27th here. I think we're gonna hit, boom, 3 billion years old. How about that? Just a few feet more, we're at September 1st. I guess not much happened in September. Well, September 16th, 1970 was my birthday, so something happened then. We're gonna keep going here. I think we're gonna hit October 1st. We come along here, October 22nd. We got multicellular life is emerging. Organisms are starting to evolve. Life's starting to grow. Things are happening. We hit November 1st. And I put right next to it, I put November 2nd, because they're pretty close. The Earth is now rotating on 20 hours, so things are even slowing down more. We're at 750 million years ago. So things are starting to slow down. Earth's really taking its shape. Things are starting to happen. Life's starting to grow. We got more oxygen coming. And here we got November 10th, 650 million years ago, the most recent snowball Earth. So again, the Earth is covered in snow and ice. And a lot of people say that's because of A lot of volcanic activity blocks out the sun, the UV rays, so everything's just really cold. Then we hear November 14th. We're now 4 billion years old. Hopefully we can see that with the shadows and whatnot. Our ozone layer is in place, and this is huge because that's what really blocks out the UV rays, and Earth is more of a, I guess, inhabitable place. You don't have all the dangers of the sun. It kind of paves the way for more complex life forms to start to really evolve. So now things are really heating up, getting tricky here, because we don't have to move that much, and we're going to see Earth evolve. We're at November 19th. This is where we really get an explosion of life. Your Cambrian explosion of life actually begins very fast, the evolving period of forms that help really create the most major animal groups we see today. We come just a little bit more, November 24th, first fish. So now you're seeing vertebrates. That was a huge step. And then we're here at November 27th, and we got the end. There was a mass extinction going on here. About 85% of all species died off. Hold on, pardon me while I flip the page here to keep us on track. Again, let me fight the wind. Of course, the day you plan to do this, it's very windy. So then we come up to November 29th. We got arthropods on land. And in my mind, we can kind of wish that didn't happen. The scorpions and millipedes and insects, and could have done without those. Then we come up to 400 million years ago, about November 30th on our timeline. Our atmospheric oxygen nears present level, which is huge because life can now be sustained. We're at starting December 1st, and we're going to get really busy here. We're going to start trucking along December 2nd. You got your first vertebrates on land, first animals with backbones, some amphibians. We go here to, we can see December 3rd. First seed plants are coming. We got December 10th. Your supercontinent forms, Pangea. Hope I pronounced that right. We're about 280 million years ago at this point. Then just on December 12th, 250 million years. You have another mass extinction where about 95% of species died. And we'll talk about these a little bit because we got a few more. You got dinosaurs coming. First dinosaurs and mammals about December 15th, about 220 million years ago. And then we got some more mass extinctions going on here. Got the end of the Triassic period, 80% die off. And you got your pretty much the exact same time, same day on the timeline, your continent starts to break up. And you say, man, what happened to all these extinctions? What's going on? Got continents breaking up and everything. Well, this is about the time they think there was some big asteroids hitting Earth, volcanic activity. Of course, the asteroids starting to move your tectonic plates and whatnot. Things are breaking up. The continents are breaking up. Those asteroids pretty much destroyed all life as we knew it. I mean, that's most of your dinosaurs. Not all of them. Most of them died off. Here's one of my favorite, December 19th, the Brontosaurus roaming the Earth. And I kind of like this guy because, one, he survived the first two big mass extinctions, but he was like a big teddy bear. He made 60, 70 feet long, 40 feet high, just a big old guy. But he's they kind of describe him as an elephant. They're gentle giants. They weren't meat eaters. They eat plants. And I always found it interesting because some of them were actually found in North America, the United States here. Then we keep coming down. We're about December 22nd now. Earliest flowering plants. That was pretty huge because plants started to rapidly grow all across the world. So then we're getting in the nitty gritty here. We have our last big major extinction, which probably took all the dinosaurs. We would put that at about December 26th, 66 million years ago. And about the same time, just days later on our timeline, we got our modern Homo sapiens emerge. That's about 150,000 years ago. So all these would be put on December 31st because they're so close together and relatively to how old the Earth is. A little bit later, minutes really, humans nearly go extinct. Again, we attribute that to disease. You still got a lot of natural disasters going on. And then same day, we're still on December 31st, 6 million years ago, Grand Canyon formed. We all know that was a big river that carved all that. Your first hominoids, about the same day. And we got early primates here. Well, my primates got out of whack here. I don't know how that happened. They should have been a couple days before. Messed up. Must have been the wind. I'm gonna blame it on the wind. So as we go back, that's about our timeline. And then we had, I think I missed one here. Our last one should have been our modern Greek astrologers, which would have been at stroke of midnight, just before midnight on the 31st. You know, and they pretty much would pave the way, and we realized all the stuff and understood all this stuff. Looking at this calendar, we can see, the distance between dinosaurs' extinction and our modern humans is roughly 65 million years apart, but on the calendar, it's just like days. It kind of just puts into perspective, it really hasn't been that long, that much time. It kind of goes by when you're 4.6 billion years old, right? If you look at humans, pretty much emerged about 17, 18 minutes before midnight on our calendar. And then nearly go extinct just a few minutes later. Like I said, many factors came into play there. Some say it was disease, natural disasters, shift in the climate and habitat. They might have went from a really, nice nice habitat. I'll just say that, I can't say. And then it got really cold. So they just weren't able to survive. Now some say, suppose we had an Earth-like planet that was found, and astronomers think it's 1 billion years old. What would that be like if it was just like Earth? Well, what would you expect? I mean, it'd probably be still in our infancy like we were. Rocky crust, lots of water, it's raining, it's cooling. And they're probably still getting bombarded by asteroids and meteors, and probably really no life, maybe some single cell organisms, stuff like that, microscopic. And then if we take that same scenario, the scientists say, oh, wait a minute, we made a mistake. That's not 1 billion years old, it's 3 billion years old. Well, how would that planet be now if it was just like Earth? Well, they would have oxygen, right? Still not the levels that we have. But they would have multi-cell life starting and starting to emerge and whatnot. But it's still pretty much in its infancy. So that just goes to show you how much Earth from 4.6 billion years ago. As we walk down here, you can see all my signs here, and we're still going. I mean, that's a lot. That's a long time. So most of what we know as life has only come in the last, November, December. Hopefully we got a long way to go. That's about it for me. Hope I explained everything pretty well. I'm still under 20 minutes, so that was my goal. You all have a good day. I'm going to clean up here and get out of this wind.